Nope. No. They will need them next hour. Okay, yeah. It doesn't matter if you want, just put them on that, on Seth's chair. Okay, here we go. Are you ready? Thank you. Sorry about my distraction here. All right. They don't technically make you do this on the AP test anymore, like in a specific section. They used to. There was equation balancing and writing. All right, but it's still on the test, but just in various places now. So be ready for these. So here we go. Letter A. We're going to write the net ionic equation for each of the following laboratory situations. Assume there is a reaction in all cases. AP promises us that if they give you a reaction, it will happen. So don't think, oh, that's a no reaction. If you get there, then you're wrong. All right, here we go. Aqueous solutions of. So the way this is written, that means both of these things are AQ, right? Are mixed. Aqueous solutions of those are mixed. Now, it's only asking for the net ionic equation. If you are good at that, then just write it. But some of you, and I'll assume most of you, still need all of it to see kind of how it works. If you don't, do it and move on without me. So what we would do first, hopefully you have this, because I'm going to change pages. So I have space. You with me? You know what I'll do? I won't. I will use the power of drawing a white rectangle over a problem. How do we feel about that? Hey, now I have space. Yeah, it's very satisfying watching all that work I had to do just disappear. Wait, so how are we supposed to work? Fine. You can't. All right. Aqueous silver nitrate. Tell your partner the formula of silver nitrate. AgNO3. Have you noticed we've used AgNO3 probably 10 times already? That's one you should probably invest time in getting to just know it. It's AgNO3. Just memorizing stuff helps. Like today, I was able to destroy Mrs. Durant at GimKit because I knew in my head the mass of carbon dioxide was 44. So like she had a little type error, which is fine, not being me, but I didn't even look at it. I was like, oh, blew everyone away because I knew it. I memorized it. It's 44 grams per mole. Yeah. Sounds like a really fair competition. You're good, man. We're teachers. We don't care about being like fair. We care about being right. Wait, is this a share for all class? All right, so far okay. Who had this? I'm not looking. Okay, here we go. Now, they're both aqueous. We've done a million of these. We cut the metal off and just swap them places, right? So we have Ag chilling with who? Phosphate, good. Now it turns out Ag is a +1 and so is sodium. So it'll be Ag3PO4. They'll have a lot of things in common. Plus Na and NO3. Now, quick discussion with your partner, super quick. Which one do you think is the precipitate and why?
I feel like it would be sodium nitrate because Ag doesn't react with. Wait, no.
So you think NaNO3? All right, here we go. My partners rocked it. They said they knew that NO3 never forms a precipitate, right? So this would be AQ because NO3 is always soluble. which means what must be the precipitate? Silver. Silver is very commonly delivered in silver nitrate because silver usually forms precipitates, but not here. So it's something I can use to deliver a precipitate maker that was aqueous in the first place. It's really common. Silver and lead are like that. Okay, moving on. Now, I'm not done yet, right? I'm not even close to being done yet. So now you may not need this part, but I'll break it up into parts. Ag plus NO3 minus. They are apart because aqueous things are apart. Plus Na plus, and there's 3 of these. All right, plus PO4 minus 3. Then my arrow. Tell your partner why I wrote these separately. Good, because they are aqueous. This says chop them up. Okay, then my arrow. Does this have an AQ? Nope. So it must be together. Something's weird about this slate today. All right, that would be my precipitate. So I put it as a solid, and then Na plus and NO3 minus. Those are separate because aqueous tells me it should be aqueous, or sorry, apart. Okay, then the net ionic, I would cancel out everything that didn't change, which would be an Na plus, an Na plus, an NO3, an NO3. I am aware that it's not balanced yet. We'll take care of it. So I have Ag plus PO43 or minus 3 goes to Ag3 PO4 solid. I must fix one final thing. Tell your partner what it is. It's not balanced. I need a 3 here, and then I'm ready to roll. That's what we're looking for. This problem technically, what is wrong with my slate? Oh my. Maybe it's like that it's on top of all these iPads. It's struggling. The problem really only needs this. All the other stuff is great. It helps me find that. But if you knew, just look right here and don't feel dumb if you don't know. If you know PO4 is probably going to precipitate with silver, just go right here. Skip all that crap. All right. Next. Letter B. Gaseous hydrogen chloride. What? Gaseous? That sounds gross. Right. What's the formula of hydrogen chloride? It's HCl. Now, someone asked what everyone asks. Why isn't it hydrochloric acid? Okay, because it's gaseous. We don't actually ever have an acid until we add it to water. And then it breaks apart. You all right with that? So just the gas is a gas. But when it's in here, it forms an acid. All right, now it's going to be put into water. So there are some things coming up. Why don't you, actually, I don't know, that's like a really cute drawing. I'm gonna leave it there. I had a check mark on the video the other day that I think was my PR. I've never done a better check mark in my entire life. It was hard to even continue to record the YouTube video because I just stared at that beautiful blue check mark. Okay, my friends, will you try the rest of this for 2 good solid minutes? Ready? No, that's too much pressure. Ready, go. Oh, my hands smell like hot dogs. I don't actually like the smell of hot dogs. Oh. Okay, hold on. So you would think it would just be H2SO3 and KCl, correct? But it's not. Thank you, whoever said that over here. That was perfect. But it's not, because sulfite makes a salt. Here's our salt, right? And it takes water, or makes water, and it makes sulfur dioxide gas. Does that sound familiar at all?
Might have heard it once before.
Mildly close. Kind of like your parallel park the other day.
Okay.
Okay, sorry, that was uncalled for. All right.
That's better than chocolate.
Okay. I never did write it, but what state is this in? What would we say? Aqueous. Okay, so let's attack. Let's rewrite it all. So I have HCl gas plus this is aqueous. So it's 2K plus SO3 minus 2. That is broken apart because that says aqueous. Goes to arrow. We ready? H2O, that's a liquid. So do I separate it? Nope. Plus SO2, that's a gas. So I didn't separate it either, correct? Plus aqueous potassium chloride. So that's K plus Cl minus. And we're ready to roll. What would be eliminated? Only potassium. So my net ionic would be all of that. So hydrogen chloride gas plus sulfite goes to water, sulfur dioxide, and chloride ion.
So is it always part of the salt that's going to be?
The spectators, yep. Always. It's okay. Did anyone have that right? Oh, 1. Hey, that's better than 0.
1, yeah.
You guys? 3? You had it right? 2? All right. We got 2. I'm not upset. These are tricky, but you need to do them. Like they are things you have to be able to do. Here we go. Whoops, that's marker tool still. Okay, letter C. Solid potassium hydroxide is mixed with aqueous sulfurous acid. Have at it, my friends. Go. Are we ready? Solid potassium hydroxide. Potassium is K. Oh no, we had our first person wrong already. It's okay. It's not a P, my friends. All right, hydroxide is OH. Potassium's a +1, hydroxide's a -1. So it is just KOH. And this tells me it is a solid. So far, okay? All right. The next part is where we usually struggle a little bit. Sulfurous acid. OUS comes from ITE. And for sulfate is 1 less, which is SO3 minus 2, right? So we have sulfurous acid.
I'm so excited.
I'm excited.
We were just.
So it's H2SO3. Now I have a question. Is this a strong or a weak acid? Weak. How do you know it's weak? Because I didn't memorize it as a strong one. So if it's a weak acid, what do I do here? It's a liquid. That's where most kids go wrong here. Sorry.
They like what?
It's bad. I'll admit. Tim, I am so nice to you. You can forgive me, right?
Why?
We can still put it in water.
I don't think you need to go.
It does dissociate a tiny bit. It is weakly written, I will admit. All right, it should be in liquid state because it's a weak acid. All right, then I do my switching around and I get K is hanging out with who? SO3, which would really mean it's K2SO3. Then we should sort of remember family 1s pretty much always make things that are aqueous, correct? Plus what's left over? HOH, and that would be a liquid. There are no spectator ions. This is not the net ionic equation. Sad face. Yeah, I gotta separate it. It's a pain in the butt. I have to break this apart. 2K plus SO3 minus 2 plus HOH. When you do the complete, you should definitely include the charges here. Because if you don't put a plus with potassium, it just means the element, which you wouldn't put in sulfurous acid. That'd be mucho no bueno. Okay, so no spectators. That is, it's not super common, but if you have a solid plus a liquid, even if it makes an aqueous over here, uh-oh. I wasn't sure if I could get my chili costume over. Time to sneeze. All right, if you have a solid or liquid, it doesn't matter over here what they make. There's not going to be any spectators. Okay, letter D. Gaseous hydrogen chloride. We've done that before. Aqueous solution of sodium hydroxide. Ooh. You tell me, is it a strong base? Yep. Okay, I'm going to pause this, take a couple minutes. Sorry if you're watching online, get over it. This was the answer, not the red. This was like, we would say, if this was the answer. Okay, should have been in class. All right, moving on. That was so much love for me right there. I even felt it. All right, letter E, we'll try that one. Aqueous copper 2 sulfate is added to solid sodium carbonate. Most people that really know what they're doing get this one wrong. Yeah, actually, if you're like 85% there, you have a higher likelihood of getting this right than those that are 100% there. Ready? Go forth with faith. Okay, people at home, so we got this far, and then we decided there was not a red flag here. So now let's go right here. See this text right here? I put it over here better. Clarification from Friday or this minute. The red flags we learned are only red flags when the anion is reacting with an acid, i.e., when carbonate reacts with an acid, it produces water and carbon dioxide. But if it were just reacting with another ionic substance, it would remain together, which in this letter E, is that the one we're on? Yeah. It's not reacting with an acid. It's just a double replacement reaction where the metals switch places. So there is no gas formed in this. And that's where people usually have a problem. So let me. Now, if you had that problem, that doesn't mean that you're dumb. I'm actually proud of you because you thought, oh, hey, I see a red flag. Okay, so the real question is, which one of these precipitates? Copper, that is correct. This is your precipitate. There's something about this formula that you should know. Hey, this will never form a precipitate. You know what it is? Family 1 metals. They don't precipitate. Because I poured it out of a box. Like, if I could mix it into water, but this is just saying you have like a chunk of it that you're adding to the liquid. That's a good question. Okay, so let's be the relationship. Let's break up everyone that's aqueous. Cu plus 2 plus SO4 minus 2 plus Na2CO3 solid. Maybe everyone didn't hear Preston's question, but he said, well, then why was this a solid? And the answer is because I took a bottle of copper 2 sulfate, poured it into a beaker, and then I poured in powdered Na2CO3. If I had had this in water, it would have been aqueous, but I'm just adding the powder. Okay, then my arrow, CuSO, sorry, that was stupid of me.
So if it had been aqueous, it would have been a red flag?
No, because there's no acid involved.
Oh, I see.
Okay, so I look, is there something floating around that was in my aqueous on both sides? SO4, good job. So that'd be my precipitate, or sorry, that'd be my net ionic reaction. Okay, are we doing all right? F. I heard the laughing. You're amazing. All right, I'm going to do this so I don't forget. Now I'm going to pause it. So, my friends, hydrogen chloride gas. And you're like, why do they keep using that to screw you over? These are all cut from previous AP tests. So, trick you. Yep. Bubbled through an aqueous solution of lead to nitrate, PbNO3 2. Someone tell me, never mind, I forget, why, how we know this is aqueous besides the word. Because NO3 ain't never
I am an idiot.
gonna have a relationship. You are not an idiot. You're one of the smartest kids in the
I
room.
got wrong with the charge of lead, and it's given to me.
It's right there.
You can't tell me I'm not an idiot.
Well, maybe there's one piece of evidence, but usually you're pretty bright. Okay, I'm going to take H and it's going to hang out with who now? NO3. And then I'm going to ask myself, is this a strong or a weak acid? It is a strong acid, so it's AQ plus. You know, I've taught for my 19 years and I still never start far enough left to finish the problem after all these years. All right, I am left with lead to chloride, right? PbCl2, and that must be my precipitate, because if it was aqueous, a reaction would have not even happened, right? And the problem said a reaction happens. Okay, so I'm going to fast forward just to the net ionic. And remember the trick I said? Find the thing that's in both aqueous and get rid of it. So what is it? Whoops, why did I underline that? I don't know, because I'm on drugs. Oh, who said that? Oh no, it's just caffeine, it doesn't count. Okay, sorry. What is it? It's NO3. So HCl gas plus Pb plus 2 goes to H plus PbCl2. So I better put a 2 here and a 2 here, right? To make them balanced. You don't have to put a salt there, but I'm going to just because I want to. Awesome. I think I'm down to one letter left, right? They have in common. Cut them. Yep. Oh, I have more. I thought I just had one. Oh, hey, something's different about G. Oh, G. You have 1 minute to get this done. Complaints can be filed in the bomb shelter.
Oh, that was really hard.
But what's the,
Oh, that's what I asked earlier? Okay.
it's okay. She's done. Okay, if you're done, here is H and I. Take a picture of it or something, because I'm going to check that you did those two tomorrow. On G, that's fine, but get these before you leave. Wait, don't you think I should be up there in my chili outfit?
Oh my gosh, yes.
Hold on.
Everybody do your best. If it's better than the old.
This is all of them. Okay. This letter, hold on, we're out of time. Letter G. What's the net ionic equation for an aqueous strong acid and strong base? Whoops.
Don't even have to do it. It's a word.
All
No.
you said was too quick. They're like, what's the quickest one?
There you go. You okay with why that's different? What was the one word they switched this time? Aqueous versus the gas. Okay, your homework tonight is H and I. Yep. They both have red flags. I'll tell you that. Both of them have red flags or red chilies.